Lesson 2.6, increasing, decreasing functions, first derivative test. Whoa, there's my camera. So, today's lesson, we're going to learn to find where a function's increasing and decreasing, and by doing so, we're also going to find relative maximums and minimums without using a graphing calculator. So to do that, this is a big concept in calculus, understanding increasing and decreasing. We're first going to find if there's any domain restrictions. We're going to find all critical numbers. That's where the derivative is equal to 0 or the derivative is undefined. We did that in the last lesson. We're going to locate critical numbers and domain restrictions on a number line. We're going to test to see if the derivative is positive, that means it's increasing, or if the derivative is negative, that means it's decreasing. And then we're going to list the intervals and then write down the maximums and minimums. That's the x values. If asked, you will find the y values or points as well. All right, let's look at example number 1 here. Find the intervals in which these functions are increasing and decreasing, and find the local extreme points. That's the local maximums and minimums. All right, so step number 1 is to write down any domain restrictions. Cube root. You can cube root a positive number or a negative number. There are no domain restrictions here. So our next step is to take the derivative. If I have a pen that works, we got this. See this one. There we go. And to take the derivative, it's 2/3 times 1 in front. Subtract 1 from the exponent, so 2/3 take away 1 is negative 1/3. And then there's a hook. So the derivative of x squared take away 9 is 2x. So if I put this together to make it a little bit easier to work with, I notice the numerator would have 2 times 2x. And the denominator would have 3. And then the negative exponent means it goes in the denominator. So that's the cube root of x squared take away 9 that goes in the denominator. Right away, I recognize that x cannot equal positive or negative 3 because that would make the denominator 0. I also realize for a critical number, 0 is a critical number because 0 makes the derivative equal to 0. So these are my critical numbers that I get from the first derivative. I'm going to draw a number line. I'm going to label the number line using those numbers. So this is where the derivative is undefined, and this is where the derivative is equal to 0, from negative infinity to positive infinity. Now, I'm going to plug in a number smaller than negative 3. So that's, let's say, negative 4. So that's a negative. Here, negative 4 squared will be 16, take away 9. So it's going to be a negative divided by a positive. Negative 3 to 0, like negative 1, will be a negative. Now negative 1 squared is 1, and 1 take away 9 is a negative 8, and the cube root of a negative number is negative. So this is negative divided by negative. If I plug in positive 1, I'm going to get a positive divided by a negative. And if I plug in positive 4, I would get a positive divided by a positive. Now, this function is decreasing, and then at negative 3 it turns and increases. So at negative 3 is a relative minimum. At 0, it increases and then decreases. So at 0 is a relative maximum. And then at 3, it decreases and then increases. So it creates a turning point. That's a minimum at positive 3. To find the y-coordinate, you plug in. So if I plug in positive 3, I get 0. If I plug in negative 3, the answer is 0. So those are my minimums on my graph. If I plug 0 in here, I'm left with negative 9 to the 2/3. That's irrational, so I'm just going to write it negative 9 to the 2/3. And that's it. If I was going to, let me just organize a little bit. Increasing would be negative 3 to 0 and 3 to infinity. And decreasing would be negative infinity to negative 3 and 0 to 3. All right, number 2. This is going to be a challenging one. We'll do it together. A sine function is continuous, so there's no discontinuities here. So we're going to take the derivative. The derivative of 1x is 1. The derivative of sine is cosine. So it's 1 subtract 2 cosine x. This again is continuous, no discontinuity. So make it equal to 0 and solve it. So I'm going to subtract 1 and divide by negative 2. So that's positive a half. So if the x coordinate is positive a half, the y coordinate is either positive or negative root 3 over 2. This is a 60-degree reference angle. The radian would be over 3. So at 1 pi over 3, that would be positive, positive. And then at 5 pi over 3, that would be positive, negative. So that would be in quadrant 4 right here. So that's what we're looking for. Next, we're going to do a number line. Now this goes from 0 to 2 pi. So it doesn't go forever to the left or forever to the right. We're going to label it. This again, you have to know your unit circle to be able to understand if the derivative is positive or negative. So if I plug in a number between 0 and pi over 3, like pi over 4, that gives me root 2 over 2, and then 1 take away root 2 is a negative answer. Plug in an angle like pi, or pi over 2. At pi over 2, cosine is 0, so you're left with positive 1. And then if you plugged in like 11 pi over 6, cosine is positive. So, what's the other one? 5 pi over 3 be like 7 pi over 4. So cosine is positive there. That's root 2 over 2. So the 2's cross out, and again, it would give you a negative answer. So at pi over 3, we have a minimum. And at 5 pi over 3, it rises and then falls. It's a turning point that creates a maximum. So, where is it increasing? From pi over 3 to 5 pi over 3. Where is it decreasing? From 0 to pi over 3. And it's decreasing from 5 pi over 3 to 2 pi. Where's the relative max? So that's at 5 pi over 3. If I plug 5 pi over 3 into here, the y coordinate there is negative root 3 over 2. So it'd be 5 pi over 3 subtract. Now the 2's are going to divide out, and the 2's are going to divide out and just leave you with the negative times the negative, which is plus root 3. The relative minimum is at pi over 3. And then again, when I plug in, it would be pi over 3. Now in this case, sine is positive in quadrant number 1. The value of sine at pi over 3 is root 3 over 2. So the 2's will cross out, and you're just left with pi over 3 minus root 3. All right, turn the page. I know that's challenging. We're either going to get stronger or give up, right? And I know you want me to tell you, I want you to get stronger and not give up. Number 3. All right, step 1 is there's a discontinuity at 0. I'm going to write that down, even if it's not going to clear up for me. I'll keep trying. Step 2 is to take the derivative. Now, to make it easier, I'm going to write this as 2 fractions. I'm not going to give up on my camera. We got this. Let me do that. So to do that, x over 4 over 3x plus 3 over 3x there we go, right? Not giving up. And then I'm going to reduce this down. So x over 4 divided by x is x cubed. So this is 1/3 x cubed. The 3's cross out. 1 over x is x to the negative 1. So can I do the algebra here? Now the derivative. So 3 times the third, the 3's cross out. That leaves me with x squared. A negative times a positive is negative x to the negative 2. So I could also write that like this. So notice that the derivative at 0 is undefined, but it's already a domain restriction, which means it can't be a relative max or min. If I make it equal to 0 and solve it, I can add 1 over x squared to the other side. And then what values would make them equal to each other? So the answer is positive and negative 1 would make them equal to each other. And then I'm going to do a number line just with positive and negative 1 and 0, which is my domain restriction. Now 0 can't be a relative max or min, but it needs to be on my number line, so it does create an interval of increasing and decreasing. And then plug in, so if I plug in negative 2 into the derivative, so I'm going to use this right here. So negative 2 is positive 4, this is 1/4, so together that's a positive answer. If I plug in a fraction, like negative a half, this will be a quarter, but the reciprocal is going to be positive 2. So it'll be or positive 4. Anyway, when you combine them together when it's a fraction, because of the reciprocal, it's actually going to give you a negative answer. If I plug in positive a half, the same thing is going to happen. It's going to give you a negative answer. And then if I plug in any number bigger than 1, it's going to give you a positive answer. So at negative 1, there's a maximum. At 0 is an asymptote. And at positive 1 is a minimum. So if I wrote down where is this increasing, from negative infinity to negative 1, and also from 1 to infinity. If I said where is this decreasing, negative 1 to 0 and 0 to 1, you could also really write it from negative 1 to positive 1. Both are correct. The maximum is at negative 1. If I plug negative 1 in here, I get 4 divided by negative 3. And then the minimum, that's using positive 1. And I get 4 over 3. You might think, why is the maximum a larger y value or a smaller y value than the minimum? And the reason is a relative maximum means this is the largest y value in its local area. It's not the overall maximum, but in its area, this is a high y value, and this minimum in its area is a low y value. So that's the idea of a relative maximum and a relative minimum rather than an absolute maximum and an absolute minimum. All right, number 4. There are no restrictions here. Take the derivative, make it equal to 0. Now, if I divide everything by 3 and then factor it, it's negative 1 and negative 1 that factor it. So I'm going to write it as negative 1 squared. I want you to notice that positive 1 does make the derivative 0. But if I plug in a negative number or a positive number, the signs don't change. So it is increasing from negative infinity to infinity. So it's always increasing, and there are no maxes or mins. So this last function, because you need a sign change to create a turning point, this last function is called monotonic. So it's monotonic when it's only increasing or only decreasing. And it illustrates 2 important points for what we're doing today's lesson. Not every critical number creates a maximum or minimum. And even though the slope at x equals 1 is 0, the function still is always increasing. All right, Mr. G Math over and out. Until next time.